Here we're going to do a couple more problems with projectiles where we don't need a calculator. Here we see we have a 37-degree angle, and we've talked several times in the last video that if you have a 37-degree angle or if you have a 53-degree angle, that is a hint to you that what you have is a 3, 4, 5 right triangle. Now, the 4 proportion side is adjacent to the 37-degree angle, and the 3 proportion side is adjacent to, up here, that 53-degree angle. What are we going to get then for our initial x and y velocity components? 100 is to 5 as what is to 4? Well, I think won't that be 80 meters per second in the x direction? And 100 is to 5 as what is to 3? 60. So let me cross off the 3 and the 4 now. We just put those in there to help remind us, hey, when we have a 37-degree angle in a right triangle, or if we have a 53-degree angle in a right triangle, that's our hint that we have a 3, 4, 5 right triangle there. All right, so time to the top, 6 seconds. This y velocity changes by roughly 10 meters per second every second. The maximum height, we need to average the y velocities on the way up there. So it starts at 60. At the top, it will have a y velocity of 0, so its average is 30 times 6 seconds. This projectile will go roughly 180 meters high. The total time it's in the air, we are assuming, because we aren't told otherwise, that this thing will land at the same elevation it started at. And so the range is the maximum x displacement, 80 meters to the right every second for each of 12 seconds. That's a little bit tougher to do in your head, but I think most of you can do it. 960 meters. So this is how we do these problems in our head. Let's try this one. Here we're given the initial x and y velocities. The time to the top is going to be 7 seconds. The maximum height, let's see. What's v average going to be? V average is going to be 35 meters per second. And that is a little tough, isn't it, to do 35 meters upward every second for each of 7 seconds. So that one, you might have to cheat a bit and go to a calculator on that. But if you thought about it long enough, I bet most of you could do that in your head too. The time in the air, same time to come down as go up. So 14 seconds for that. And then the range is going to be 40 meters to the right every second for each of 14 seconds. How about 560 meters? What about this one? We mentioned in the last video that a 45, 45, 90 right triangle has the edge length ratios of 5, 5, 7. So what must be our initial x and y velocities here if we have essentially a 5, 5, 7 right triangle? Well, if this is 70 meters per second, then the initial x velocity is 50 meters per second, and the initial upward y velocity is also 50. That means it's going to take 5 seconds to get to the top. The maximum height, we need to average the y velocities in getting to the top. 50 plus 0 divided by 2, that's 25. 25 meters upward every second for each of 5 seconds, roughly 125 meters in height. We're assuming it's going to land at the same elevation it was launched from, 10 seconds in the air, and the range then 50 meters to the right every second for the entire 10 seconds, 500 meters. Let's do the same thing here for a problem that looks a little bit nasty, but we can pretty much get an idea of what our answer is going to be without even getting our calculator out. So how are we going to do that? This angle right here is sneakingly close to 53. And we know that if we have a 53-degree angle here, that's a 3, 4, 5 right triangle, with the 4 being that side and this side being the 3. All right, well, what must these velocities be then, the initial in the x direction, the initial in the y direction. This launch velocity is about 25. 25 is to 5 as what is to 3? Well, isn't that about 15? Same thing over here. Let me cross off this 3 now. Same thing over here. 25 is to 5 as what is to 4? How about 20? Cross off that 4. Cross off the 5 now. See, without a calculator, that's about 15, and that's going to be about 20, which means what? Time to the top, about 2 seconds. Time in the air, about 4 seconds, assuming it comes back to the same elevation it was launched from. How high is it going to go? Well, let's see. If I'm pointing over here at 20 meters per second upward, at the top, it's going to be going 0. So the average would be 10. For each of 2 seconds, the maximum height is going to be 10 times 2, roughly 20 meters. And what about the range? The range is going to be about 15 times 4, about 60. That's how you do it. If you were to take the time to put all this into your calculator and figure out what you get, what you end up with are numbers that look like this: 20.33, 14.72. The time to the top is 2.075. The time in the air is 4.15. The maximum height is 21.1. And the range is 61.1. Look at that. We did a pretty good job just by using our brains.